Welcome to Pomodoro Joe for Tuesday, August 22nd, 2023. Today we're looking at LeetCode problem 168, Excel sheet column title. This is an easy problem. Given an integer, column number, return its corresponding column title as it appears in an Excel sheet. For example, A is 1, B is 2, C is 3, and Z is 26. Okay, AA is 27AB. So I'm not super familiar with these column titles, but it looks like we'll go A through Z, capital letters, and then it goes AA, but then does it go AAA? I guess when you get to AZ, then it goes AAA after that. That'd be my guess. All right, well, let's put 25 minutes on the Pomodoro timer and get started. So this is very similar to another problem we've done in the past where we had to convert a digit to, or an integer to a string or vice versa. I can't quite remember, but basically we need to take whatever we're given. In this case, we're given a number. So I guess the equivalent would be taking a number and converting it to the string representation of that number. So we'll need to find, I guess, whatever is in that ones place first, in the ones column. Then we'll find what's in the tens column, hundreds column, and so on and so forth. In this case, these are not really ones, tens, and hundreds. These are mod 26s. So whatever's in the 26th column and whatever's in the 26 squared column. So yeah. All right, so we'll treat this as if it were a standard decimal number, but we're going to use base 26. If that makes sense. So the first thing I'll do, let's create some mapping from a number to a letter. So let's have a mapping. And that's just going to be all the capital letters from A through Z. All right, hopefully I got them all. So if we're given a number, we can convert that to a letter fairly easily, but that number has to be less than 26. Okay. Let's see, what else do we need? Well, we'll need our result, and that'll start as an empty string, and we will return that at the end. I'll just put those together. Next, we're going to be taking our column number, this column number that we're given. We'll be doing a divide by 26 and a modulo 26. The modulo will give us our current letter that we're looking for, or the index into our mapping for the current letter that we're looking for. And the divide will basically give us the next letter or the next value in which we're looking for letters. So we'll have some column number. All right, now while this column number is greater than 0, so again, we'll be doing two things. We'll get the modulo, which gives us our index. That's the remainder of what's left over. And we'll do a divide. And that column will become the new, or that division will become our new column number. So for example, if this were, again, a base 10 number, we might have like column mod 10. This will give us, oh, let's see, let me get index here. What do I call this? I'll call it remainder. So when you do this percent sign, that's called a modulo. And that will give you the remainder of, if you divide a column, integer divide by 10, what's left over. So if column were 1, 2, 3, 4, 5, 6, 7, 8, or 9, you'd get the same number back. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because like 8 divided by 10, or integer divided by 10, would have 0, remainder 8. Now if this were 11, 12, 13, 14, like 18, so something like 18 modulo 10, so 10 divided by 10, or 18 divided by 10 would give you 1 with a remainder of 8. So in that case, 18 modulo 10 would return 8. Okay, so in this case, we don't do modulo 10 though. We would do a modulo 26, because that's going to give us our, basically our ones column. And then whatever's left over is column integer divide by 26. Okay. Now we need to do our lookup. So our result will equal whatever we look up in our mapping for this remainder. Maybe I'll change that to index. And then we'll just append that to the front of our current result. So we'll do the ones place first, and then we'll do the tens and hundreds and so on, and we'll keep putting those at the front. All right, I'm going to change this to index because that'll make it a little bit clearer. And then this is just our new column. So in fact, this is just our column will become our column divided by 26. Okay, and that way our column will be reduced each step along the way. Now, one thing I am not doing, I'm not accounting for this not starting at 0. So in this example, A is 1. In our case, A is at index 0. And so if we do a column modulo 26, if this column were column 1, which should be A, and we do modulo 26, we'll get a 1 back, which will actually give us a B. So how do we fix that? Well, let's look at the other end as well. If we had column 26, now column 26 should be Z, looks like. Now 26 mod 26 doesn't give you a remainder, you get 0. So we would jump back to A. So what we really want is to shift our column down by 1, because our column 1 should be index 0. So we'll do column -1 modulo 26. Okay, so now in this case, our 1, column 1 becomes a 0 mod 26, which is 0, and that gives us A. 26 becomes 25 modulo 26, which gives us 25, which gives us index for Z. All right. And I basically have to do the same thing here. So when we do our divide by 26, we have to do column -1 divided by 26. Again, if we had 26, so 26 divided by 26 would give us 1. We don't really want any remainders after we're at column 26. We're at Z, and that's the last thing. So we really want to do 25 divided by 26, which will return 0, which gets us out of our loop. Okay, I think this covers it. Let's give it a shot. Okay, that works. Let's submit this to see how we do. And we pass. And we do pretty well. We beat 88% for runtime and 23% for memory. So yeah, that's not too bad. We can jump back here. I don't know, there's not much I can do. So there are things that we could do with this mapping. So I'm using a mapping because it's easy, it's simple, it's straightforward, you can see what it's doing. There are things you can do with looking up numbers based on their ASCII values. For that, you would use the ORD function. So ORD of some value or some character, like A, that will give you the ASCII value of A. And you can do then an offset from like our index. So that would be our offset, get a new value back, and then you can convert that value back to a character by using the char function. So you do char, whatever it is, 56. Whatever you get back from your offset plus your A, your ORD of A, you can put that into your char function and that returns a character. So we could do some math instead of doing this lookup, but I think the lookup's pretty convenient. All right, one thing we could do, we could try collapsing some of these, like give it less space so it doesn't have to, I guess, parse as many lines of code. We could try that, see if it makes a difference. No, it makes it worse. That's surprising. All right, one other thing we could do. We're doing this column -1 more than once. So we could do something like this. Call equals call -1. And then we could do this. See if that makes a difference. Not really. We're at 74% and 63%. All right, if we really want to get this over 90%, we could try the ORD thing. We could also try just changing these names. So we'll try M and R. I don't recommend this, but hey, I'm trying to get a 90%. All right, so we've minimized this pretty much as far as it will go. Let's see how we do. I need to change that one. Try that again. Nope, still at a 78%. So hey, I'm gonna have trouble breaking that 90% on this guy. All right. Nope. All right, we'll try the ORD thing. I don't think it's going to be any faster, but we'll try it. So instead of this map, okay, so we were doing a map here. Now instead of doing this map, we have to do this lookup. So let's see, I'm going to have our base. So the base will be the ORD of capital letter A. So all of our indices will just be offsets from this base. So instead of doing our map lookup here, we will have to do character for the base plus this index offset. All right, let's see how this goes. Still works. Let's see if this is any faster. Nope, it's actually slower. Now we're down to 71% for runtime, but we do a lot better in memory, 89% for memory. I don't think I'm going to get this one over 90%. Let's take a quick look at what other people are doing. Oh, so they're doing the same thing. They just happen to be a little bit more compact here. And they're not creating a local version of this. They're just using the input version. So, all right. So yeah, basically the same thing we're doing. One thing we could try, we could just swap these around. Let's see if this makes a difference. Nope. Man. All right. Well, I'm going to leave it up to you. See if you can beat me on this one. Get a 90+%. Go for it. I challenge you. All right. That's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.